All right. Good evening, everybody. Good evening once again. So, I have taken bath, and now we will we will continue. There are like 10 questions or something, but since we were grinding since the morning, it might take some time to continue, to go forward, and to maintain the same level of progress. So it takes time, but that is what we need. If you don't push hard until the end of what you can, then you are not using your life properly. You can be better. You can do better. All right. So let's continue. Let's push. Let's push today until the very end. Okay. I did something. Yeah, we are here. I mean, in my opinion, solving a previous year paper completely and understanding the concepts around it as well in a day is is okay. I mean, it's not the greatest feat in the world, but it's okay. Please, where are we, man? We are at 44, and how many we got? We got 55. Just 10 questions, right? That's it. 10 questions. That's it. We are here. So, this is the order of page numbers. Let's list them out. So what we were asked, page faults were asked, and if you look at the algorithm, I mean, I have read the question and analyzed it before. Like, okay, I might be using more space than needed. Yeah, the thing is, I was saying like I have analyzed the question before. That's why I am doing what needed to be done. These are the page numbers, and how is the frames? How are the frames? The frames are like OS predicts 4 page references at the time of allocating a frame to a page. So when you need to allocate, is like when you have a fault. When you got a fault. That is how a page replacement algorithm works. It doesn't shift all the times. Optimal page replacement algorithm. Right. It doesn't look ahead all the times. So there is nothing here. There is nothing here, so we get 1, and this is a fault. X indicates fault, okay? And we need 1, and we got 1. We need 3 now. We have 1, so we will allocate it, and it is a fault again. We need 2. We don't have 2, so we will allocate 2, and it is a fault again. So we need 4, and we do not have 4, but we have a capability of looking at the next 4 pages. We can look up to this, and what can we remove? Do we need 3 in the future? So we need 3. So we need 1, 3, 2, all of these. So we need 1 at the very end. So since it is optimal, we will replace 1 with 4, 3, and 2. It is again a base fault. So, alright, 4, 3, 2, 2 was there and no fault. 4, 3, 2, and 3 was there, no fault. And again, you need 1 over here. And from 1, you can look at another 3. So, 4, 3, 2. 4, 3, 2. You don't want 3, you need 3 at the last, so you can replace 3 with 1. And again you got a base fault. Got it? And 4, 1, 2, you got it. 4, 1, 2, you got it. Again at 3, you messed up. So you can look at 3, 1, 4. You need 1. Alright, you need 1. You need 4, you don't need 2. So you can replace 2 with 3. And again you got a base fault. 4, 1, 3. 4, 1, 3. So total 6 base faults. And we solved it in exponential time. But still, we solved it. Did we not? We solved it, man. That's good. Alright. Tables, database of a sports league. Player has player ID, player name and age, team has team ID, team name, city and city ID. Coach has city ID and city name, members has player ID and team ID. An SQL query was given, select minimum of pH. P is from player P, where player not PID in, player not PID in. Select M of PID from team. Okay, members PID, members PID. Select select player PID from members PID, where mark coach not there is no mark. And C or coach, there is no mark, right? Okay, I can see. Oh fuck, am I blind? There is mark here. T dot CID is equal to C dot CID and M dot TID is equal to T dot TID. This is a 2-mark question, so that makes sense. Select minimum of P dot age. Select minimum is player from here absolutely such that P dot PID in M dot PID 1 2 3 4, everything has 1 2 3 4, and C dot C name is equals to mark. Okay, mark. So the coach is mark. Team dot CID is equal to C dot CID. 1 or 2. MI team M dot TID. M dot TID is equal to T dot TID. What is T dot TID? T dot TID 10. Team ID is 10. So 1 comma 3 are returned. 1 comma 3, minimum of 1 comma 3 is Ishan with age 26. 26. Okay, these people are giving a lot of elevation to set to. I got to see set to. Let's see. Which set is harder and 2025 KTs. It doesn't matter. We will do. 5-bit messages transmitted from source to destination through a noisy channel. The probability that mm, the probability that the bit of messages get flipped during transmission is 0.01. Bit of message. Flipping of each bit is independent of another. The probability that the message is delivered error-free to destination is. So it is a 5-bit message. Okay, you need the distribution. So all bits are transmitted correctly. So 0.01% probability that is it the same? Omkaran. Okay, I guess it is the same. Yeah, it will be 00. It will be 1 and 10. 3, 4, 5, 6, 7, 8, 9, and 10. There will be this much. So it will be 0. Okay. It is more of a probability question than of a computer networks question. So, firstly, we do not have a base on probability. Okay. If you were to compute error in 1 bit, 2 bit, 3 bit, 4 and 5, that's mess. And again you need to subtract it from 1. So instead there is 99% probability that there won't be any error. And for 5 bits, right, that is 99 times 99. Do we have cache here? Gate calculator. How does gate calculator? Let's see. Virtual calculator. Okay. 0.9. Okay, that will be calculator and gate. Okay, we will master that out. We will use that. Sure. Okay. This is 2 marks. Message of size 15,000 bytes is transferred from a source to destination through IPv4 protocol via 2 routers. Each router has a defined maximum transmission unit, including IP header. The number of fragments that will be delivered to destination is 15,000 bytes. So you need to know the size of header. You need to know the size of header in this one. Cache is here again. IPv4 header size is 20 bytes. Okay. Okay, kind of understand that. IPv4 header is 20 bytes. 8 bytes are allowed. Multiples of 8 bytes. So 5000 bytes, including header. So 4980 is actual capacity. If you do by 8, 6 or 48, that will be 1. 8 twos are 16, that will be 2. And 8 twos are 16. Point something, and if you multiply by 8, 8 twos are 16, 8 twos are 16, 17. 4976 will be why not 4984, because there won't be any space in data packet. 4976 and 20. Whole is not multiple of 8. Just data. Kind of understand this. What will be last fragment? 4, 9. Let's open that one. What? Okay, need a reminder. 15,000 minus. $72 reminder. 32. 3 packets. That's good. So it will be, and again, you need to look at how 4976 data packets, they will be divided into 3000 size data packets. Obviously, 3000, that will be 1976. No, actually 2980. One nine nine six. That will be 6 packets plus 72 packet. That's it, 7 packets, and we did it. Probability distribution density function. X square. So 0, 1, 2, 3, and 4, and 5. So for x less than 1 and for x greater than 4, this value is nothing. Here only it will be a probability distribution. X square. X square. Integral of 1 to 4. X square dx is equals to 1. Okay. It is constant. 1 to 4 x square dx is equals to 1. X cubed by 3. 4 to 1 is equals to 1. Alright. That's 64 by 3 minus 1 by 3. That is 63 by 3. C. Yeah. 21 3 is equals to 1. C is equals to 1 by 21. Okay. Once you got the same value, so 2 to 3, 1 by 21 x square dx 1, sorry, 1 by 21 x cubed by 3 to 2. That's 27 by 3 minus 8 by 3. How much is that? 19 by 3 into 1 by 21. That's 19 by 63. 0.302. I see. Okay. That's basics of integration. Why don't we do that? 19 by 63. Huh? You motherfucker. 19 by 3. 0.301. We got it. Finite state machine with one input x and one output f represented by given state transition table. The minimum number of states required to run as a surface is present state here. I have never seen a question like this. Present state is A. Mm-hmm. Now the marked entry pairs has the same transition and output is so they can be merged. Can I understand what's going on? Okay. State minimization problem for a mailing machine. Mailing. State and input. Yeah, I have. I have heard about maybe and more machines. Really? Oh my god, I thought I shared my screen. Let's see. All right. So initial partition outputs. Maybe machine output depends on current state and input. Two states are equivalent. For every possible input sequence, they produce the same output sequence. If their output pairs and successor states fall into same equivalence class, they can be merged. State minimization algorithm. So you got it. FB. A, B, So FB 1 how did he come? The market entry pairs. I have understood that. Alright, you know what? We will get this table and we will draw something. So FB00. Do we have an FB00? No, we don't. DC00. These two and FE. No, we don't. Do we have any GA? 0 These two, they can be mapped out. So BE is written and DH is written. So remove it and remove it too. What now? F is giving. So you can write it BE00. C also BE00. So AC can be mapped to this. So C is removed as well. FBE, we don't even have an F. Okay. This is 1, this is 2, this is 3, This is 4, this is 5. That's it. No further simplification is possible. We got it. 49 questions. Oh my god. We got into digital logic again. The circuit is initialized with some initialized the number of distinct and the circuit will go through before returning to. Okay, this is clock. This is a flip flop. Okay, I see. Johnson counter. Yeah, I guess this is what we are talking about. Characters. The input of the input. Number of distinct states the circuit will go through before returning back to initial. Okay, people, 5 more questions remaining, and how many minutes? It's been 48 minutes. Okay. Expresses key of next terms of current input. Johnson counter D naught. D1 is equals to Q naught. Okay. Peak and initial state. Assume initial state when you have 0. Okay. Okay. Oh, I see. So, we got the D naught is equal to the try dash. Let us start with the initial sequence of 0. D naught, D1, D2, D3. and again this is 1 and 0. D3 is again 0. 1, 1, 1. It will be again 1, 1. Now what? D3 will be 0 again. Now it will be 0. The number of distinct states. It went through 7 distinct states. Okay, that's good. We are left with 5 more questions, people. I don't know, it may take 1 hour or something. Okay, that is a function that takes array and size. If size is equals to 0, return 0. Size is equals to 1, return 0. If size of 0 is not. Okay, if the first element is not equals to second element. That's good. 0, 1, 2, 2, 222, 00, 11. Okay. So size is not equals to, no, size is not equals to 1. 0 is not equals to 1, so it will call 1 plus 4, size of 1. It will be pointing to 1 now, and it will get 8. And this will call again. It will call, 1 and 2 are not equal. It will call this again. And the pointer is here now. So this call will return, wow, so 3, 6. So the pointer is here again. It will return 4 of s of 4, comma 5. The pointer is here now. It will return 4 of 5. Okay. 2 and 0 are not equal. So it will return 1 plus 4 of s of 5, comma 4 now. The pointers here now, they are equal again. 4 of s of 6, comma 3. The pointers here now, 0 and 1 are not equal. 7, comma 2. So the pointers here now. So 1 and 1 are not same. Sorry, 1 and 1 are same. S of 8, comma 1. So since the size is equals to 1, it will return 1, it will return 2, it will return 2, and it will return, that is 3, and it will return 3, it will return 3, 1 plus 3, it will return 4, 5, fuck. What? This is a moment of celebration and congratulations to me. Okay, no one's here to celebrate the victory with me. Okay, data on next. Suppose the program has created a linked list. Nice, a linked list question. L1 contains 9 nodes, 1, 2, 3, 4, 5, 6, 7, 8, 9, and L2 contains 7 nodes. It modifies the number of nodes. Code segment is. Okay, find query list of list. While list is not equal to null, if list of data is equal to square root of 1. Okay, we are finding pointer L1, pointer to L2, while pointer 1 of next is not equal to null. Query is equals to pointer 1 of no. Pointer 1 of next of data. Pointer 1. Yeah, you are not checking pointer 1 of data. Okay. If find query comma L2 okay, is that into main? Okay, there is some problem with this. Gates is 2025 sent one paper. Let a list. Do we have this? Yeah. We found the question. The number of nodes. Okay, the number of nodes that will be there after execution of the code segment that was asked. I kind of forgot what the question was. That's it. So we are going through this. Query is equals to pointer 1 of next of data. This is pointer 1 of next of data. This is query. If If query is found in Alto, if query is found in Alto, what are we doing? Pointer 1 of next. Point this, suppose query is found here, it will be linked to this one, so this will be skipped out, something like that. So 1, so pointer 1, it is pointing to, let's do this, 1 7 12 3 9 5 11 15. Okay, that's why I genuinely hate this. 1 11 6 9 15 12 1 4. So this is PTR1 and this is what? PTR2. PTR1 of next is not equals to null. If find query, alright, for query, if it is found in this, okay, if it is not found, now this is PTR1, 12 is found. 12 is found and it is removed. So it will come here and 3. It won't check 3 now, it will check 9. 9 is found. So wait, we are not tracking a pointer 2. It is a formal parameter, no worries. Now it is pointer 1. It won't check that, it will check 11. It will go 15. Now this is, it won't check 15, it will check 8. So 1, 2, 3, 4, 6, 6 or 5. The values 11, 11, 9, 12, 15. So 9, 5, 11, 15 and 8. If you check this here, right? 5, when 5 is pointing here, right? 11 is found. So now this is P1 is pointing to P1 is pointing to. Now query will become no, what I'm trying to say here is 11 is found. So P1 will point to this one. Now this is query is 18, right? I mean query is 8. I don't know. Okay. Twelve removed. 9 removed. Yeah. Kind of made sense. Somebody asked the same question. If you look at the code again of if block, pointer 1 becomes pointer 1 of next of next. It is not moving P to next node, it is just updating 5 to next node. Okay. So what is this guy saying? In the if block, if the query is found, pointer 1, this is pointer 1, pointer 1 of next. This part becomes pointer 1 of next of next. Okay, yeah, pointer 1 points to 15. Pointer 1 points to 15. Now we need to find 8 only, right? If you look at the code of if block again, pointer 1 of next. Moving P to next node, it is just updating 5 data 5 next node. Ah, okay. Pointer 1 of next went to here, but not the pointer 1 itself. I had the same goddamn doubt. Wow. So let's do this again, shall we? 1, 7, 12, 3, 9, 5, 11, 15, and 8. And again it is 1, 11, 6, 9, 15, 12, and 4. We are not updating pointers. We are updating the next parts. Pointer 1 points to that. Alright. So now, what is it? Well, pointer 1 of next is not equals to null. Query. Query will be initially what? Pointer 1 of next. Of next. This is pointer 1 of next. This is query of pointer 1 of next of data. Query will be 7. And if 7 is found, 7 is not found. So now pointer 1 here, pointer 1 is updated. Here pointer 1 of next is updated. There is a lot of difference. Wow, wow. Now this is pointer 1 pointing to, okay, 7. Now query is 7 of next of data. Now query will be 12. Did we find 12 here? Yes, we found 12 here. The link initially gets broken and this link will be formed. And if you notice, the pointer is here only. Now pointer 1 of next of data. Now the pointer is at 7 only. Now we are looking at 3. 3 is not here. So now the pointer moves. Got it? Yeah, got it. Now the pointer moved. And what are we doing? Query. Query is equals to 3. No, now we will get to query is equals to 9. Yes, query is equals to 9. So this one points to this one. So this one's removed and this one's removed too. Alright, the pointer's here only. And now pointer 1 of next, okay. Query is equals to pointer 1 of next of data. Now we will be checking 5. 5 is in here. No, it is not in here. So it will now go here. Now are we going for 11? 11 is in here. Yes, it is in here. So this pointer moves. And the pointer is still here. 15. Now comes real play. So 15 is yes, and now 15. 15 is here. Yes, 15 is here. So pointer 1 of next. It will point to pointer 1 of, this is next of next. Pointer 1 of next of next. It will point and these two will be skipped. So what do we have? 1, 7, 3, 5, and 8. Oh my god. Yeah, there are. I got it, man. I got it. C program get takes a number and dt new number turn new number is equals to turn is equals to 0 while n is greater than or equal to t times 10. Okay. At the end it will be divided by 10. When t is greater than 0. Wow. So 1, 4, 3, 6 and 2. Okay. Nunam is equals to turn is equals to 0. T is equals to 1, they were initialized, and n is greater than or equal to t. Huh? What? N and is this number greater than or equal to t? T is 1. It will always be greater than or equal to t, right? Arey babu. Consider the following C program. नहीं क्या हुआ? Yeah. Am I missing something here or what? Guess I'm missing something here. Okay. We are missing something here, absolutely. At the end, it will come out to be a very silly one, I swear to God. Are we missing? Okay. Because there are no brackets, man. I don't take no for an answer. Oh, God. No. Okay, what's your problem? This is my problem. Yeah, this is my problem. In this part, don't we need, because 1414362 is greater than or equal to 0, and t will be as I told you. I thought it is n times 10, bro. So silly mistakes. Yeah. So t is equals to 1. N is greater than or equal to t. 14362 is greater than or it is equals to 1. Now t will be 10. N greater than or equal to 10. It will be 100. It will be 1000. It will be 10k. It will be 1 lakh k, and now t will be 10k. While t is greater than 0, d is equals to by t. Got it. Got it. 14,362 by 10k. That will be 1. D is equals to 1 and n is equals to n mod t. N mod t. What? 4,362. That will be the value of n. And t will be 1000 now. Now d will be n by t. What is n? 4,362 by t. N by t. Okay. That will be 4. And now n is equals to n mod t. N mod t. That will be 362. Oh, nice. Now 14362, that is 4 3s. Now d is equal to 3, n is equal to 62. Now d is equals to 6 and n is equals to 2. Okay. T will be 100 by this case and t will be 10 by this case. So d is equals to what? N by t. 2 more n by t. 0. N is equals to n mod t. N. That is also 0 if I am not wrong. If turn was not touched this initial time. Turn is equals to turn plus 1. Turn is equals to 1 mod 2. That is 0. Did not track until the end of for loop. I will eat and then I will come back. It is almost 1 hour 30 minutes and then you see we will continue.